Hello. So now with respect to the exponentiation, I want to show you one important property that we're going to use a lot here. So we know that x raised to the a power times x raised to the b power is equal to x to the a plus b power. So the first thing I'm going to do is I'm going to show you how we would use this. And I'm going to start with a numerical example so you guys can see that this is not as abstract as it looks. Then we'll walk through a slightly more abstract example, and then I will give you some justification for this. Okay? Okay. So let's say that I had 2 squared times 2 cubed. If I followed the rule, then see, I have the same base, okay? They're both 2's. So, and I have different exponents. They don't have to necessarily be different, but they're exponents. So what this rule tells me is that I would just, my result from this multiplication would be 2 raised to the 2 plus 3, right? Which would be 2 raised to the 5th power, okay? So that's using the rule, okay? That's what this rule tells us. Now I'm going to show you that this is not entirely out of whack. So if I were to look at 2 squared times 2 cubed, using our definition here, I would see that I can replace 2 squared with 2 times 2, right? And again, why is that? Because I'm going to have 2 copies of the base 2 being multiplied together. I have 2 copies of 2 being multiplied together. Okay? I can now, so now I can replace 2 cubed with 2 times 2 times 2. Why? Because I'm going to have 3 copies of the base 2 being multiplied together. So I have this situation over here. Now again, as I mentioned earlier, because of the associative law and the commutative law, I know that that multiplying these 5 2's here, that this breakdown into 2 parenthetical expressions of 2's being multiplied will make no difference on the final result. And so I can get rid of the parentheses, and I get 2 times 2 times 2 times 2 times 2. Okay, or in other words, I have 5 copies of 2 being multiplied together. But by definition, if I have 5 copies of the base 2 being multiplied together, what is that? That's 2 to the 5th power. Aha. So if I just use, so what we saw was that using this rule, I get that by using this rule, I can get 2 squared times 2 cubed equals 2 to the 5th in a very straightforward manner. If I follow the definition, I get 2 squared times 2 cubed equals 2 to the 5th by following this procedure. So what we have just shown is that this rule, which gave us this easy result, is satisfied by this example. And also this example shows us what's happening behind the scenes, okay? Of like how this rule came to be. Now I'm going to show you another example, okay? And this example is going to be a little more like what we're going to see in algebra. But I don't want you to panic yet either. And but anyway, so if I have x squared times x cubed, right? I'm going to use the rule first. Aha. I have the same base, okay? I have the a is 2, the b is 3, right? And what's the product going to be? The product is going to be x to the 2 plus 3, okay? And then, oops, okay? But what is 2 plus 3? That's x to the 5th. That's using the rule. As before, I want to show you how this meshes up with what we would normally think of, okay? So I'm going to rewrite the problem. X squared times x cubed. So I can rewrite this multiplication problem, okay? I can replace this x squared with x times x. Okay? I can replace this x cubed with x times x times x. Why? Because I have because this notation tells me I'm gonna have 3 copies of this base x being multiplied together. And again, because of the associative law and the commutative law, I can see that this 5x's being multiplied, these 2x's being multiplied first, and these 3x's being multiplied second, and then the product being multiplied, can be replaced simply by the 5x's being multiplied together. And again, as we can see here, I have 5 copies of x being multiplied together. Here in my notation, I have n copies of x being multiplied together, gives me x raised to the nth power. So I know that this has to be x to the 5th power, okay? X to the 5th power. So again, I see this rule works, and this rule, I think by now you can see the pattern of what's happening, okay? So now, I don't want to call this an explicit proof of this property, because like there are some details I'm going to leave out, but I want you to see this so you can have the idea of what's happening. So in general, this property, the way that this property can be seen is that now, and by the way, guys, if you don't want to, this part that I'm about to do is going to be slightly abstract. So if you don't get it on the first view, don't worry about it. We're not going to see it in the examples, but I just want you guys to see this once, okay? At least once, so that you can appreciate it. And then of course later, it won't prevent you from doing any problems if you don't understand it now. But anyway, let me do it real quick here, and then we'll move on to some more properties and examples. Okay? Okay. That's great. Okay. So this product, x to the a times x to the b, is equal to, first, I'm going to replace the x to the a. What can I replace it with? Well, I know that if I have x raised to the a power, I can replace it with a copies of x. Okay? So x times dot 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 times x, where I have a copies of x being multiplied, right? A copies. And then I'm going to put my multiplication sign. Now what is this x to the b? This x to the b can be replaced by b copies of x being multiplied. B copies of x being multiplied. Okay? But now, again, here is where I'm basically hand waving. Basically, because of the associative law and commutative law, this multiplication of a copies of x first, this b copies of x first, and then those two products being multiplied together to get the final product can be replaced with how many copies of x being multiplied? A plus b copies. So here I would have x times dot 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 times x, where there's a plus b copies, right? A plus b copies of x being multiplied together. But what is that? That's nothing but x to the a plus b. And so we can have faith that this property applies. Yes. Now, of course, I'm doing it just for integers, but it will apply more generally than that, and you'll see that as we move along. But I want you to see it. I want you to see this idea so you can have faith from where it comes from. Okay? Thank you.